Okay, continuing on to part 3. We're going to talk about percent yield and what this has to do with chemical equations and how to calculate it. So, in the real science field, chemists use percent yield quite often. It tells you how efficient your reaction was at producing what you wanted, and it lets you compare to what you actually got out of a reaction to what you expected to get. So, a theoretical yield, this is what we have been calculating the whole time. This is, in theory, what you should get when you do this, when you do a reaction. So if you have a reaction and you calculate based on however many grams of starting material that you have, your theoretical yield would be the maximum amount of moles or grams that you would be able to get out of a reaction. This is different than what you would actually get out of a reaction. So once a reaction is finished, you would weigh the amount of material that you got out of it, and this would be your actual yield. The actual yield is the amount of actually produced product. So let's say that you did a reaction like this. NaOH plus HCl goes to NaCl plus H2O. And you calculated that you should get 10.0 grams of water out. But, so if you calculated that you would have 10 grams of water, this would be your theoretical. And I will abbreviate it theo. If your actual, after you were done with the reaction, was only 7.00 grams, then this would be less than your theoretical yield. And I'll tell you right now, this is going to be 70.0% of what you expected to get. Basically, it's how close you were to getting what you wanted. The way that it's calculated is you will take your actual yield, divide it by your theoretical yield, multiply it by 100%, bada boom, bada bing, there you go. That's your percent yield. So, if we're talking about the reaction that we did in part 2, where we have A and B reacting to make C, and we determined that 8.33 grams of carbon should be produced. This is our theoretical yield. 7.23 grams of C is what was actually made, which means that this is what was recovered. This is your actual yield. If we want to find the percent yield of a reaction, we need to know these values and use them in the equation that was previously shown. And so this is how we would do it. We would take 7.23 grams, the amount that we actually got, divided by what we should have gotten, multiply that by 100%, and our value is going to be 86.8% yield. Percent yield. And this is how close we are to the mark. This was our basically our accuracy to what we were expected to get. Okay, try this out, and then we'll continue. All right, so the reaction is 2S plus 3O2 goes to 2SO3. We were able to produce from this reaction 1.50 grams of SO3 produced from 1 gram of O2 and excess sulfur. Now, sometimes these percent yield and limiting reactant problems limiting reactant. These problems can be part of the same problem. However, it's a good sign that you won't have to deal with that if the word excess is applied to one of your reactants. So instead, we can just focus on the O2. So since we know we have an excess of sulfur, we don't care about the limiting reactant. Our O2 is going to be our limiting reactant. So this is how we will do this. We'll start with 1.00 grams. We'll make one of these, and we'll find, first we need to find what our theoretical is. So 1.00 grams of O2, we'll say that O2 is 32.00 grams for every 1 mole of O2. For every one, Then, once we were in moles of O2, we will use this and this to find out what the ratio is. So 3 moles of O2 for every 2 moles of SO3. Now we know what the mass of our product was, which means that we need to match the units in order to calculate the percent yield. So we need to find out what the mass of our theoretical yield would be. And so if we have 2 moles of SO2 for every 1 mole of SO2, SO3, that gives us 80.03 grams for every 1 mole of SO3. I'll put the word mole here of SO3. We'll multiply the top, divide by the bottom multiplied, and we will end up with 1 times 1 times 2 times 80.03, divide that by 32 times 3 times 1, that gives us 1.667 grams of SO3. This is our theoretical yield. And so the next step is to take our actual yield divided by our theoretical, actual over theo, multiply that by 100%. That gives us 1.50 divided by 1.667 times 100%. We end up with 89.96, which ends up being 90.0. Now, the closest to that is going to be C right here. And so if it's a multiple choice question, then you're just going to want to get as close as you possibly can. And that is in percent. These are your units for this kind of problem. And so that's what we end up with. All right, try this one, and then we'll keep going. Okay, so this one is a little bit different. We will need to kind of reconstruct this percent yield. So remember that the equation is going to be actual over theoretical times 100% gives us percent yield. In order to find out, we need to produce 85 grams of PF3 in this reaction. And so we need to get our theoretical to be something that is going to be larger than 85. And so we'll have to do a little bit of algebra to this, or we can, that's really what we're going to have to do. So in order to do that, we will multiply both sides by theoretical to resolve for the theoretical yield. So multiply both sides by theoretical. That's going to cancel out this right here. And we will divide both sides by percent yield. Divide both sides by percent yield. And so that comes up with actual divided by percent yield. These will cancel. Times 100% equals theoretical. Now, we know what our actual is. We know what our percent yield is. We know we want to find out what the value is that we are going to find for a theoretical. From there, that is going to be of PF3. We can then find the mass of P4 that we'll need. So I'm going to plug those numbers in. Our actual is going to be 85.0. This is what we want. Our percent yield is 64.9. Multiply that by 100. And we end up with 85 divided by 64.9 times 100. 130.97 grams of PF3. So now that we have this value, we can use stoichiometry to figure out what the mass of P4 is. And so we are also going to need the molar mass of PF3, which is 87.97. 87.97 grams per mole. And for P4, that's going to end up being 123.90. So that is 123.90 grams per mole. So we'll set this up like this. We'll start with the theoretical that we just calculated. We'll make another train track. 130.97 grams of PF3. We need to get that into moles, so we'll use the molar mass. 87.97 grams for every 1 mole of PF3. We will do a mole jump, so we're going to go from moles of PF3 to moles of P4. So for every 4 moles of PF3, there are only 1 moles of P4. And for we need to get back out of that because we are looking for the mass. For every 1 P4 that we have, we will have 123.90 grams. And so all we need to do is multiply the top, divide by the bottom. 130.97 times 123.90. Divide that by 87.97 times 4. We end up with 46.12. For sig figs, we can round that to 46.1 grams of P4. And that should be our answer. Ta-da! Okay. All right, that's all that there is for today. Thanks so much.